Welcome back. Welcome back. About, I think it was a couple weeks ago, I mentioned hooking up one of these agentic harnesses up to Azure, hooking up, I think at the time it was OpenClaw back when I was exploring the hype into it. It's cool. It works, but it definitely has its bugs and its security issues. I much prefer OpenCode, which is a lot more secure because it doesn't hook up messaging services to it, right? But we're going to use open code. We're going to be using GPT 5.4. I would be using Gemini, but I hate to say this, Gemini has been disappointing me recently. Google has lobotomized Gemini, and I'm pretty sure I know why. GPU compute is very expensive, and they've been shoving Gemini into all of their services. They're running a Gemini search for every single Google search there is. That's got to be very compute expensive. Not only that, but they're selling Gemini Pro, which is, I'm pretty sure, doing like recursive thinking in order to increase the quality of the results. And something's got to give somewhere, and that somewhere is in Gemini Chat, which has noticeably gotten dumber over the past week or two. Have you noticed? I noticed. I use ChatGPT, Gemini, and Claude, depending on what I'm trying to achieve. And I definitely noticed Gemini all of a sudden started giving some very, very mid answers, from low tier answers, okay? So for right now, we're doing ChatGPT. And I'm going to share with you my workflow for building out a skill in something like open code. All these harnesses more or less work the same. You could do this in open code. You could do this in OpenClaw, though I highly advise hooking up your OpenClaw to your Azure environment. You could also do this using anti-gravity or VS Code. Anything that has SSH or shell access should be good enough. In my case, I'm running open code in a Linux container, just to keep things simple here. They say pictures are worth 1,000 words. And I felt like it'd be easier just to give you a diagram. We're going to be walking through this concept than for me to try to. We have open code right here on our home lab right here, which connects to Entra. Inside of Entra, we have our Entra lab environment. We got our users, our virtual machines, our Azure, whatever stuff, app registrations, whatever stuff we need inside of Entra. We're going to see how good open code and ChatGPT is at stuff like that, right? How effective of a tool is it? At first, I'm not going to have it spinning up servers yet. My budget doesn't quite allow it, okay? I need to put some more money aside. The last time I played around with Azure, I came out of my pocket a little bit deeper than I thought I was going to come out of pocket, okay? I need to put a budget aside because I am interested in seeing if it can do stuff like spin up Kubernetes clusters without much interference. That was a very tedious process. I also want to see if I can get it to shut them down so I don't keep getting billed for my experiments. That would be worth the $20 a month. Before we get started, let's talk about this architecture a little bit more. We're not just running open code, it's not just like talking to ChatGPT. Open code is an agentic harness with full access to your system. Open code isn't just ChatGPT, but in the command line. It's a lot more powerful than that. Open code is an agentic harness. That means it can write scripts, read logs, run commands, and connect to network. It is effectively putting a fully enabled self-acting agent on your network. You shouldn't do it lightly. There's good ways to set it up and bad ways to set it up. The advised way that I've figured out is setting up a service account, limiting access to what commands that service account can use, and more or less just using open code for one purpose. Now, is that the way I am running it in my lab? No! I gave it full permission, boys. Full send to all my servers and services. Right, we here to learn the hard way. That's what lab environments are for. If you're afraid to break things, how do you ever learn anything? Yeah. And over the past couple of weeks, I've learned a lot. I've learned a lot about how harnesses work, tool callings, what models are worth spending money on and what ones aren't. All right. I've also learned that during different times of the day, you're going to get different levels of performance. It's really interesting. But I've also learned, or at least I've realized, there's a common philosophy when it comes to making tool calls. Now, we've all heard of MCP, or Model Context Protocols, which are basically, hold on, let me draw this out for you. MCPs are basically servers you run in your network, separate from your AI server, right? And what happens is when you want a tool, maybe like searching the web, the model calls the MCP server, and the MCP server does the tool calling. That's one way to do tool calls. It works, there's lots of benefits to it in that you get structured data, right? But it kind of has a downside in that it basically turns your tool call into a black box. A request goes in, a request comes out. Maybe you get some failure modes, right? Versus you building a interface for the model to interact with. An interface would sit inside of open code, right? And a lot of times these interfaces are either markdown skills, or they're markdown skills in Python or Bash or PowerShell scripts, whatever system you're running your host on. But regardless of whatever system you're running your host on, you would do open code. You would create an interface. And what that interface would do is be a wrapper for a set of scripts and tools. So you would build an interface, and this interface right here would normally be written in either stuff like Python, Bash, PowerShell, whatever system language that you're running the agent on. And this interface would actually be the one doing the tool calling for you. So instead of the MCP server, the model would make calls directly from that interface to whatever service you had on the back end. So the main design philosophy here is the difference between having your batteries included or having the batteries outside of the server for whatever tool calls you. In our case, we're going with batteries included, boys, right? This is the main advantage I found to keeping your interface local to whatever harness you're running it on is that it gives you flexibility. You can iterate over quicker, whereas your MCP server is static. It's one thing. And sure, maybe if you had control, well, you should have control to the MCP backend, and you should be able to update it at will. But it's a whole different service. The benefit there is that it's a whole different service. It's separate. You can do a lot more configuration, right? The downside is that it is a whole different service for you to maintain. Whereas by keeping it as just a script or a wrap with your agent harness, you get modularity, you get logging, you get the ability to, while it's trying to solve your problem. It's no longer just, I need this tool, let me send it off, and I get the response back and proceed. It's, I need to think how to use this interface, right? It's an additional level of context the model process. But, it's interesting. In our case, for this example, we'll be going with setting up a local interface just because it's easier, right? We're probably going to have to install PowerShell for Linux in order to get the intra connector stuff working properly. And then we're going to see if we can get open code to manage my intra home lab, create some test users, clean up some old test users, maybe nuke any subscriptions and services I still have left over from when I was doing my AZ-104 labs. But we'll see how good it does. It's just getting a brief overview of how the environment is staged, right? We'll start with that. So before even getting started with building the prompt, you'll probably want to log into Azure and build a user that has the right permissions. If you want this to manage users, you probably want to give it the help desk admin role, right? If you wanted to do more than that, you probably want to give it, security admin or global admin, whatever permissions for the account you'll be using against Azure with. Then you'll need to install either the latest version of PowerShell if you're on Windows, or PowerShell on Linux if you're on Linux. In my case, I run OpenCode on Linux, so we will be going with PowerShell for Linux. So this was a long prompt. I had to sit down and think about it for a second. So I basically told it to do research for Linux and PowerShell for Linux, as well as the Azure and Entra models. I then told it to install PowerShell for Linux, its Azure Entra models, and make a skill that lets you review Azure Entra environments. I then define what the skills to grab, domains, users, server, services, virtual machines, containers, yada yada. And then I just kind of define how I want the skill to behave, which is to have a set of scripts, and then you have a master script that acts as a command line interface that dynamically calls those subscripts and can pass variables to them. This basically lets the model kind of build dynamic commands to pull info. It doesn't have to on the fly come up with a command. It has a predefined way for it to get the information it needs. This is going to save it a lot of time later. Fix that. And so we just hit it off. We wait a few minutes and we see how long it takes for it to do this. All right, so it identified it was a complex task. It's going to go ahead and do some research, inspect the environment, install Azure and interrelated PowerShell modules. Now, the smart way to do this is probably to spin up a remote server and, have that remote server run the main scripting logic, and then just have the model run like a get script, or a set script on the remote server. But we're not doing that. We're doing it live, boys. We're risking it all, writing the script on the machine, and then we're going to run it, right? Hopefully the AI hasn't gained sentience and slide something dangerous in there. It could. I'm not checking the code. I'm just trusting it. And it's still going. It's like 20, 30 minutes later. So I'm still trying to code out the skill. Looks like it got Azure, Entra, and PowerShell installed. So good job so far, ChatGPT. And we're waiting for it to finish designing the skill. And we're going to do some live testing. In the background, I've been applying some permissions, We're going to see how well it handles this. I was trying to see, well, we might have to change the login method. Maybe do like an app registration and give the app registration API call permissions. But first we'll try with just my regular Azure admin account. And we'll see if it has the right access it needs to do this. All right, so it looks like it used Python and what else? PowerShell. Yeah, it used Python and PowerShell. So good job. Let's go ahead and test this skill out and see how it works. So the skill finished building out. And before we can proceed with testing, we have to make a app registration. Thankfully, it printed out some information about how authentication works, right? It says we have to connect an an Azure account. It looks like it depends on a app registration. So we'll make an app registration provided the app registration details give the app registration the right permissions and go from there. I already have my Azure tenant pulled up with Entra. We're just going to go to app registrations, new registration. We're going to call this agentic test. And then we just register, right? When that happens, you'll get a directory ID, but you'll also need to create a client secret as well. So you'll click client credentials, add credentials, new client secret. And we'll call this agentic secret test. Real quick add. I'm gonna have to blur all this out. Cool, we now have our app registration. We have our client secret. We have our tenant information. Let's go ahead and proceed with testing the skill. I'm just going to copy and paste that info into open code real quick, and we'll go from there. Oh, once you've created the secret, we then have to assign permissions on it, right? If we go back to open code, it tells us what permissions we need, right? So required scopes depend on the query. I need domain read all, user read all, group member read all, application read all, role management read directory. So I'm pretty sure I know what role gives that permission. Let's go to API permissions, add permissions, and we'll just type in read. Now we're back on open code. We've created our app registration. What we then need to do is figure out what API permissions we need. So what API perm do I need on the app reg? And let's give it a second for it to think. Cool. So it told me everything I need to know there. So first, let's go back to our app registration and let's grant it admin consent. Grant admin consent, yes. Cool. Then we have to assign the perms it needs. So it needs enter graph. It needs read all permissions for enter graph. So let's see. Right. And we can just type these in. We can do organization. And we can do organization dot read all. Then we need domain. And we can do domain dot read all. And we can do group. And we'll do group dot read all. And we'll do device. And this particular process is tedious just because it's going to take a while, right? I'll be back in a few minutes after I've granted all the permissions it needs to be granted. We're back on the app registration. So let's go back to API permissions. As you can see, permissions are assigned. You're going to have to grant admin consent to your permissions after you assign them. So I just did that. After that, you're going to want to copy and paste your application ID, tenant ID, and client secret into open code or whatever other harness you're using. In my case, I'm just going to hit a quick copy here. So I copied my client secret, I copied my app ID, my tenant ID, and my client secret. Let's go ahead and see if it can read my domain. So let's do this. Add that to a dot secrets. So what I did was I pasted that info in and told it just add it to a local file. There's much better ways to handle this. This is like the least secure and recommended way, but we're not being secure. We're trying to see if we can get this to work first. And then we go back around and we lock it down, boys. Right. So we'll wait for it to, it's probably going to realize the file doesn't exist. Go ahead and make it, right? And then it's going to test the connection, which it looks like it's doing already. So we're back. It did some testing. The enter portion is working. The Microsoft Graph portion is working because I didn't add those API permissions to the app registration. But the app registration is working. It made some changes. It made a .secrets file, and now it loads that .secrets file from the skill environment. So cool. I just got to add more perms to this. And that's it. Yeah, we'll be able to at least have re-level insight into my Azure environment. Right? Let's see. What can you see in Azure right now? Report on what you can see right now. So I told it, let's see. Run an Azure skill against current credentials to capture visible inventory and permission boundaries. Summarize what is going to be visible versus blocked. So I told it to just, do some investigation with the perms it does have right now. Let me know what it sees. And we'll be back when it's done. The one thing I like about AI is I can tell it to do something, walk away, and come back and see the results. I don't got to be there. My laundry pile has slowly been diminishing. Something I realized I forgot to do was to grant the app registration the reader role on a subscription. So I went back and took care of that. Let me show you on the screen real quick. You go back to IAM, role assignments, and now I have a agentic test user, or I guess application, right, with that role on it. And let's do this. I can probably go to properties. There we go. We can even see our serviceable principal sign-ins. We had one just a minute ago, agentic test. And that is the harness or open code or chat, yeah, whatever you want to call it, connecting and running the report right here, which shows our subscription. What I'm interested in is it's claiming that we don't have the right read permissions in Microsoft Graph API. When I explicitly went and granted those. So we got some investigation to do. But it is pulling Azure information, which is very useful. It's showing my resource groups, generic resources. It's showing the subscription itself. I only have one for now. And I like that. No key vault, app platform, containers, web apps, VMs, or anything like that. So also had to go back and add application permissions. So when you're setting this up, you're going to need both. Let's see. Delegated. Notice we have application.readAll and application permissions granted, as well as grant admin consent for all these permissions in order to get this to work. Once that's done, we can come back to this page and we can test it. So let's tell it to try the test again. App parent and role should not be assigned. So let's see what it does this time.